Now focusing on perpendicular lines, recall that to be perpendicular means that the lines intersect, but not only intersect, they have to intersect at exactly the angle of 90 degrees. So it does turn out that this blue line and this red line are perpendicular to one another. They do form a 90-degree angle, but you can't just do that upon inspection. You have to prove that. And so what we're always going to see be true about perpendicular lines can be exemplified in this example, where if I compare the slopes, so that line's slope is going to be 1/2, and then this line's slope is going to be -2/1, or just -2, then what we're always going to see be true is that if you take the product of their slopes, so product mean multiply 1/2 with -2, you're going to get an answer of -1, and it turns out that you will always get an answer of -1 when you multiply two slopes that are lines that are perpendicular with one another. So we can summarize that by saying that any two non-vertical lines are going to be perpendicular, so intersect at a 90-degree angle, if and only if the product of their slopes is -1. Okay, there will be another way that I'll explain that in just a little bit, but for right now we'll hang on to that definition. One kind of exception to this is if you have a vertical line and then a horizontal line. It turns out that if this has a slope of 0 and this has a slope of undefined, when you do 0 times undefined, you have a huge problem right there because undefined is not a number. And so you're not going to be able to get -1, so it's kind of one exception to the rule. So that means that any vertical line and a horizontal line are just perpendicular by default. All right, so now, like I was saying, another way that we can think about perpendicular relationships can be exemplified in kind of a different way other than just saying the product of their slopes is -1. So just some recollection for us here. So opposite numbers are opposites, like, you know, like -3.5 and 3.5 are, of course, opposite. Now, we really think about opposites as numbers that are equidistant, so equidistant from 0 on the number line, which of course is true, right? The absolute value of -3.5 and 3.5 is both 3.5. Now we also call opposite numbers additive inverses. And when you think about the inverse property of addition, right, it's just adding two opposite numbers and then it'll equal 0. So asking for the opposite of 5 or asking for the additive of inverse of -3/4 really are the same questions because opposite and additive inverses are the same thing, right? So clearly those are going to be the opposites of those particular numbers. When we're dealing with reciprocals of numbers, a reciprocal of the number n is actually 1/n. So when you think about the reciprocal of -3, it ends up being 1/n. And then the multiplicative inverse is just another fancy word for a reciprocal. So if you're finding the multiplicative inverse of 8/5, you can just flip it, and it is 5/8. And the reason why that is because if you do treat it as like 1/n, so 1/8/5, then you just do keep, change, flip, and then lo and behold, right, you get your 5/8, and that's going to be the reciprocal. So when you're classifying relationships between numbers, it turns out that right there, -3 and 3 are only going to be opposites, and then it turns out that -5 and -1/5 are only going to be reciprocals. But when you have a kind of a combination of both elements where one of your numbers is negative and the other is positive and then they're also reciprocated, we've got what we call opposite reciprocals. So what opposite reciprocals are going to be numbers that are opposite in sign, so one's positive and one's negative, and you also have basically reciprocals. So if you're trying to find the opposite reciprocal of a number, say 5, you just reciprocate it, but then since the first one was positive, then this one's going to be negative. For -3/4, it's just 4/3, but now it's going to be positive instead of negative. This one would end up being positive 1/3, and the last one would end up being -5/8 for opposite reciprocals. So it turns out that whenever lines are perpendicular, it does turn out that the slopes are opposite reciprocals of one another. So if you had two lines with slopes 5 and -1/5, then those lines are actually going to be perpendicular with one another. And it turns out that in all of these cases, that if you do multiply them together, you do get -1. So it still fits that definition of being perpendicular. So when you're asked to show if lines are perpendicular with one another, you do have to show that the product of their slopes is -1, or show that the slopes are opposite reciprocals, because that's kind of doing the same thing. So if we're to try to show that these are perpendicular, we're going to have to compare the slopes. So for this line right here, if we find the slope, let's do 4 minus 1 to get the change in the y's, and then 2 minus -4 to give you the change in the x's. So you end up getting 3/6, which is a positive 1/2 slope. And then for the other line right here, if we find the change in the y's, so let's do, how about 5 minus -4, and then -2 minus +1, you end up getting 9 over -3 right there, which would end up giving you, -3. So what we're able to say then is if we compare 1/2 with -3 there, they are not opposite reciprocals, because you would need like a -2 or a 1/3 correspondingly to actually have opposite reciprocals. So they are not perpendicular. So let's call this, how about line M and this line N. So if we were to compare line M with line N, if they were perpendicular, you draw this symbol, which basically just looks like a upside down T, if they were perpendicular. But however, because they are not perpendicular, then you can just draw a slash through it to show that they are not perpendicular with one another. And then in this example right here, you can see that if we find the slope of that line right there, we're going down 2 and then over 6. So you get a -2/6 or -1/3 slope. And then for this line right here, it's up 3 and over 1, so you get a +3 slope. And it does turn out that those right there are opposite reciprocals, or if you multiply them, it would equal -1. So therefore, we can say that line XY and line UV here are indeed perpendicular with one another.